in Unit 1, we're going to talk about trig, and we just practiced that unit circle. So that's kind of a basics around everything we're going to do. But different than grade 11, when we talked about everything in degrees, we're now going to add the language called radians. Okay, so what is a radian? A radian is an angle measure where when you cut around the outside, the distance of what I call, this is an arc, this would equal the radius. So on a circle, let's pretend your radius was 15 centimeters. Okay, do you know what I mean with an arc? It'd be like if you could put a shoestring around the outside. That's the distance, right? You can't measure an arc with a ruler, right? Because it's curvy. So as soon as you travel a shoe length on an arc of 15 centimeters, then that angle that you go through is considered 1 radian. And you've secretly worked with this before. Where? Does this ring a bell? Have you ever figured out the circumference of a circle? Circumference equals 2 pi r. You've done that before. Or pi d. Okay, so that's the circumference. Do you know what a circumference of a circle means? What does the word circumference mean? The whole way around. The whole distance around a circle, right? Okay, so if there's 2 pi radiuses around the circle and 1 radius equals 1 radian, we also can conclude that there's 2 pi radians in a whole circle. So that's important to know. There's 2 pi radians in a whole circle. Okay, let's talk about a whole circle in degrees. What do we know about that? 360. So 2 pi radians is a whole circle, so that's the same as saying 2 pi radians is 360 degrees. And are you okay if I divide both of these sides by 2? And I'm going to get the conversion. 1 pi radian equals 180 degrees. So you're going to see this a lot. Pi equals 180, pi equals 180. You're going to see that used together. And that's where it comes from. Okay. So what I want to do is I want to write the 4 quadrant angles as a radian value. Okay, so let's start. Obviously 0 degrees is 0 radians. We nailed that one. Does anybody know, okay, this is 180, right? 180 equals pi. Does anybody know a number for pi? 3.14-ish. So, what's it to 3 decimal places though? 3.142. How would I figure out this top? What would I do to get the number there?
Divide pi by 2.
Divide pi by 2. So I'm just in my calculator doing that. 1.571. Okay, what about on the 270 spot?
Add those two numbers up together.
Add those ones together? I would not have gone there.
But does
That works.
work?
Yeah. I never would have done that.
Yeah, that's what I would do.
Oh, that was nice.
Never would have gone there. That's interesting. That's good. What else? That's good. Do that. You're going to get the answer.
4.703.
Okay, this is what I'm doing. If this is a half, this is 1, this is a half, this is 1, this is 1.5 times pi.
I'm gonna write that down. Sorry.
That would make some more sense.
True.
But it's okay, but 1.5 pi, I'm gonna eventually, we don't need to do it right now, but I'm gonna eventually write it as 3 halves, right? Does that make sense? But what am I doing? 1.5 pi's 4.712. And 360 is what? So this is a half, this is 1, this is 1.5, this is 2 pi. Okay, it's crazy to think that in degrees you go all the way up to 360 on a wheel. In radians you only go to 6.28. Okay, so it's a huge difference in values, right? Radians are very small compared as numbers. Okay, let's try to divide a circle into 1, 2, 3, 4, 5, 6. So if this was 1.5-ish at the top, I don't know, 1 would be like there.
Like we're dividing the top into 3 and the bottom into 3?
Well,
Or like what?
this is 1.5, so I don't know where 1 would go to. This is 3.14, so 3 is obviously, yeah.
Oh.
So, you probably misunderstood this, but how is your 6 point, like, is radian equal to pi?
1
Radius, right?
1 pi, which is 3.14 radians, is 180 degrees.
Okay.
So I need,
Radian is equal to radius.
right, like, see how I cut this into 1 radian?
Why didn't
So
you just
this,
do it right down the middle?
this would be 1 radius length.
But isn't like the top, you said it was 1.5, so wouldn't 1 be exactly like at,
Well, I don't know, it's 1.57, so
oh, okay, sorry.
it's a little bit closer.
Like just a little bit over half.
Yeah, I don't know. And then 4 would be in this quadrant, right? 5 is in this quadrant, right?
Sure.
Because this is 4.7. So 5 is after that. And then 6, because you have a little bit left over, right? Because you have to have 6.28. So, Yuri, the question that you're asking me, let's pretend your radius is 15 centimeters, right? See that? That's 15 centimeters. This chunk is 15 centimeters.
Oh, that's,
This chunk is 15 centimeters. This chunk is 15 centimeters. This chunk is 15 centimeters. This chunk is 15 centimeters.
and there's always 6
Point
radians.
28.
Oh, right.
Yeah. Does that make sense? Or, like, you know what? Does that make sense?
It's how many centimeters? One? What?
Or whatever your radius is. So if I had a radius,
Equal to the radius.
then this arc distance would be 15 and this arc would be 15. It'd all be the radius amount. Okay? Okay, so how do you draw 2 radians? So when you draw an angle, I need your quadrant. And I need you to give me a swivel and like a clock arm. So 2 radians would pivot, pivot, pivot about there. Does that make sense?
Yeah.
Because I had 1.5 in my head at the top. Okay, 6 radians. What's instantly in your head when you think about 6 radians?
All the way around.
It's close to the whole way around because the whole way was 6.28. So I'm going to go almost the whole way around.
Don't say 9.
And look around a couple times.
Okay, 9. Somebody already said we're swiveling around and then again more, right? Like turning in a circle. So here's what I'm going to do. 9 minus 2 pi.
Why?
Because 2 pi is one rotation. So I'm going to go 2 pi and then I'm going to go 2.717 more. Okay, so I'm going to go
Is that 2?
full circle and then 2.7-ish more. Where would it be? Somewhere in? Mostly grading it, are you in the right quadrant? Ish.
That's good.
I mean, if it's obviously closer to the 90 spot or the 180 spot. Okay, what is going to happen if I put a negative in front of the rotation?
It would go down.
It's going to start pivoting that direction. That's what negative means. So down. What's in your head when you think of 3 radians?
Almost up the line.
Almost a 180 move, right? Because 180 is 3.14. So almost a semicircle backwards, downward.
Is it even that? That's one of the rounds up.
Right, so there's 2 rads.
Okay, so we're going to learn how to convert degrees to radians, radians to degrees.
That's what we were talking about, yeah.
Okay, I'm going to show you the long way twice, and then that's it. We're going to do short way. So 70 degrees. I'm going to go like this. 70 degrees equals blank radians. I'm going to set up a ratio.
Yeah.
And what do you know? What's the conversion that we boxed up on the other page?
The 2 pi rad or something.
180 equals how much? 1 pi.
Just pi rad.
I mean, if you use the 360 and the 2 pi, you're going to get there, but this is simpler. How do you solve for my blank? What's the method of math that you would use here?
So about pi rad on both sides.
Just like a simple, what's the general theme to the solution on how to technique this? What's this technique called? Anybody remember?
On algebra.
Crisscrossy? Cross multiplication. which two items would you want to multiply and which one would you divide?
Chris says no cross.
He doesn't like it.
Which ones would you connect on multiply? 70 times pi divided by 180. And do you know that in pre-calc you have to accurately round everything to 3 decimal places? Exactly.
No, it didn't.
Thought so.
Or I deduct you points.
Does that mean that I have to like put in pi manually?
Yes.
So I can-
If you tried to use 3.14, you'd be off. Yeah. Do you not have a pi button? You have to have a pi button
Wait,
somewhere.
does that give me 3 decimal points?
What?
Does that just give me 3
Well, your pi button gives you infinite. It uses an infinite number.
points?
Does this number make sense to you? 70 degrees is there. Does 1.2-ish radians make sense? Because the top was 1.5-ish, right?
He's probably.
Okay, let's go radians to degrees. Okay, so here's what I'm doing. 2.93 radians equals something degree. And then what's the thing we know? Pi and 180. Make sure you line up your ratios together, right? Pi, 180. You know what I mean? Your t-shirts and your pants have to be the same order. And do you figure out which ones you would times and divide?
Isn't it pi rad?
You might have ratios.
Divided by pi rad. Not rad, just pi.
So you're going to be timesing by 180 and then dividing by pi. Do we have a prediction before I type it in? 2.93. It's less than 180.
171.496.
Good guess.
170 or 167.
Dang it.
You would have got part marks.
So imagine if I go, okay, no exam for me.
Okay,
No, I wouldn't write for the exam.
I'm done setting up ratios and cross multiplying because here's the trick. You have two options. The one option is that you're going to times by pi and divide by 180. And the other is you times by 180 and divide by pi. Here's what I always remember. Divide by what you want to get rid of. Okay, so I'm in degrees. I'm in degrees. So therefore I want to get rid of degrees. So then you put 180 on the bottom.
So we already put it.
So I would times by pi over 180.
Should times by what you want to get rid of.
Divide
5.
by what you want to get rid of, because that would cancel, you know what I mean? That would cancel the units that you're in. So if you're in degrees and you divide by degrees, your degrees are gone. Okay,
2.5.
let's try one more. I don't know why I put so many on this chart. 5 radians. So you're in radians. Times, which one? I always do the bottom first. What do you want to put on the bottom? What do you want to get rid of? If you're in radians, you want to get rid of
Radian.
radians. So put pi on the bottom. So 180 over pi. So you always just remember there's two options. And if you forget that little rule, you just go back to your ratio cross multiply.
That's so specific. Kind of nice. Over 180. Maybe you do. Oh, it's a decimal.
Okay. Now, you know that we just did the unit circle and we did it in degrees. You always are going to now do it in radians. Yeah. Amped it up a notch there. So let's talk about these numbers. They're all in our unit circle, right? Okay. Tell me, how do I get 30 degrees? I would need to take 180 and divide it by what? 180 divided by what?
Why?
It gives me 30. Just numbers.
Oh.
How about 18 divided by what gives you 3? 6.
60.
180 divided by 6 makes 3. So, this is degrees. So in radian form, pi over 6. That's how I get it. I just replace the 180 with a pi because they're equivalent. Okay, just numbers. 180 degrees, how much would you have to divide it by to make a 45? What do you think? 180 divided by what number? 4?
18.
So, as a radian, that's called pi over 4.
Oh, look at us.
Okay, we're buzzing. Go.
How do you get the number 60 out of a 180? 180, you'd have to divide it by 3. So whenever you hear me talking about 60 degrees in radians, I'm getting pi over 3.
1. So this was just pi.
Yep.
Okay, we did this one already when we talked about this one. What did you tell me to do? Take pi and divide it by 2. Hello? Yep. Do you know that was Miss Tana? Okay, what did you write? Did you do pi over 2? Is 180 divided by 2? And these are our main ones. 180 is
1. Just pi.
just pi. And 360 is 2 pi. Those are the numbers that you're going to have memorized because you will use those and use those. So let's put them on our unit circle.
So you need to just 1/6 of pi.
2 times pi.
No, but 30 is 1/6 of pi.
Okay, so we're going to do it on this page, and then I'm going to, right after, you're going to practice on your white page after. Okay, everybody flipping your page of your notes, this is where you are. Okay, let's go the main 4. Can you give me the main 4? So give me a 0. Give me the top, which is
0.5.
pi over 2.
Oh.
Yep.
Yeah. Good enough. Good enough for the bird.
Give me the 180 side.
0.2.
Pi over 2. What's the 180? Pi.
2 times.
How do I write the bottom one? Do you remember that fraction I used?
Oh.
We have a half, a 1. This is a 1.5, which is 3 over 2. So 3 pi over 2.
Why don't you just write 2 pi?
This one's 2 pi.
Oh.
Oh.
And 2 pi.
Oh, yeah. We forgot about that.
Okay? Those are your 4 big ones, right? The 4 corners. I'm sorry, I'm trying to be in and out here. Good? Okay. Now we're going to do all the 30s. So when I say all the 30s, I'm doing these 4. Those 4. Okay. You ready?
Go.
This is where we're going to blow your mind, and you're going to be like, this is how I'm going to do it. This 30, we already know, is pi over 6. Okay, this is the most helpful tidbit I'm going to give you for the whole unit. When I think about pi, here's what I'm going to put into my head. 1 pi is 6 over 6. Does that make sense to you? The number 1 as a number, you can make it a fraction, 6 over 6.
Yeah.
So this is 1 less.
5 out of 6.
So it's 5 pi over 6.
Because just 6 pi out of 6 would be
Exactly the 1 line, yeah, 1 pi.
That's hard.
Okay,
7 pi 6.
what is having 1 more? Remember in my head, this is exactly 6 over 6. So this is 7 pi over 6.
Like 2 over 12.
Okay, now in my head, the number 2, are you okay if I think about it as 12 over 6?
Yeah.
Does that make sense? So this is 1 less.
11.
So it's 11 pi over 6.
Come on, man. Not yet, don't say that.
Okay, now the 45s. So all the 45s. So I'm going to start with 45, which is pi over 4. Okay, I'm putting a new number in my head. The 1 pi line is now going to be in my head as 4 over 4. So 1 less is 3 pi over 4.
Because the middle one would be 2 pi over 4, and that one's 1 pi over
This is technically 2 over 4, yeah,
4.
which got reduced, yeah. And what's this 45 degree?
Or 5 out of 4.
5 pi over 4, because this line again was 4 over 4. What's the entire circle if you want to write 2 as a number, but 8 over 4? So then this one is now 7 pi over 4. Okay, 60 degrees. So the original is pi over 3, right? 60 degrees. Pi over 3 is how I get 60. What are you going to put in your head for the 1 pi line?
3 over
3 over 3. So this one should be 2 pi over 3. And in this quadrant, I should have 4 pi over 3. The full thing is 6 over 3. So the missing one is 5 pi over 3.